Good morning. I'm going to take you through how to set up your JK synchronous counter. So first I'm going to go through the steps and then I'm going to take you through each of these steps. So the steps are to develop the state diagram, then develop the present state next state transition table, then simplify the input expressions, and finally implement the circuit. So the first step is to create the state diagram. Once again, here we are going to create a 2-bit counter, so we are going to use 2 flip-flops. That should be noted. Again, our 2 bits, we see the states will be 0 0, then it will be 0 1, then it will be 1 0, then it will be 1 1, and then go back to 0 0. So this is our state diagram. With this, we then go in to create our present state next state transition table. So what are the present states and what are the next states? Well, here you can see AN and BN. These are your present states at the output. Here you have AN plus 1 and BN plus 1. These are your next states at the outputs. So here we write down all of our present states. So 0 0, 0 1, 1 0, 1 1, and then we place the next state, what the next state should be. So according to our state diagram, 0 0's next state will be 0 1. 0 1's next state will be 1 0. 1 0's next state will be 1 1, and 1 1's next state will be 0 0. So these are the present state and the next state. So we use these so that we can figure out what the inputs need to be so that we can create the present and next state. Here we have to take a look back at our excitation tables which we would have created. So here you can see I have the JK flip-flops excitation table, and we'll just go through the first row for you. So JA and KA are the inputs for the A counter, the first one. So we look at the present state is if the present state is 0 and the next state is 0. For JA, we look at the excitation table. 0 0, J will be 0, so we place the 0 in here. We look at K now. For 0 0, we look again 0 0, K needs to be X. X in this case is a don't care. It can either be 1 or 0, it does not matter. So we place X here. Next, we go and we now look for JB and KB, which will be for the second counter, the second flip-flop, I apologize. So we look, BN is the present state, BN plus 1 is the next state, 0 and 1. So we look for JB, we go here, 0 1, J needs to be 1, so we place 1 in here. And then we look again, 0 1, K needs to be a don't care, so we place the don't care in here. Alright, now I'm gonna take a short pause so that you can fill out the rest of the table yourself. Alright, so this should be the table which you have as well. If it's not, then obviously correct it. Now with these, with the inputs now filled in, we can simplify the expressions. So there are different ways we can do this, and the one we will be using is K-maps. You can also use Boolean algebra and the QM method, the Quine-McCluskey method. Now this method works when you have many flip-flops in your counter. So for the more complicated ones, it's a little bit more difficult to use, more tedious, I should say, to use Boolean algebra or K-maps. So the Quine-McCluskey method is used there. But once again, we have a simple counter here, so we don't need to use that. So for the K-maps, we're going to have 4, and I'll just take you through each of them. So again, this one will be for JA, as can be seen. So we look for JA here. A and B, you can see A and B. So for 0 0, J is 0, placed here. 0 1, J is 1, placed here. 1 0 is a don't care, placed here. 1 1, don't care, placed here. Next, for K, 0 0 0 is don't care, placed. 0 1, don't care, placed. 1 0 is 0, placed. 1 1 is 1, placed. For JB, here, 0 0 1, placed. 0 1, don't care, placed. 1 0 1, placed. 1 1, don't care, placed. And finally, you can see for KB, 0 0 is a don't care, placed. 0 1 is 1, placed. 1 0 is a don't care, placed. And 1 1 is 1, which is placed. Alright, as can be seen, if you group them, you can see that for JA it will be equal to BN, which is the output of the B flip-flop, the second one. Same for KA, it'll be BN. And for JB and KB, you can see that both outputs will be equal to 1 since everything is grouped. So what we will do now is place the circuit diagram in Logisim so that we can take a look at how we implement the circuit. Alright, now we can finally go on to the last step, which is to implement the circuit. So again, this is the setup that you should see in your tutorial, and I'll just go through the logic that we found from the simplified expressions. So we'll start with the second flip-flop first. We look at KB and JB. We can see that their inputs are equal to 1, a high input. So that's what we do. We go ahead and we connect each of these inputs to the same 1 value, and that's it. Now we go to KA and JA and see that the inputs are connected to BN for both, which is the output of this second flip-flop B. Did not note the names, apologize. A and B. So yes, this flip-flop here, B. So again, we just connect the wire from this flip-flop, and we just connect both inputs to here. We connect both inputs of A to the output of B, and that is it. That is the entire counter right there. To see, we'll first go to our state diagram to make sure it's working properly. Press simulate, enable ticks, and see it starts at 0 0, then 0 1, then 1 0, then 1 1, and then back to 0 0. So as you can see, this counter works exactly how it needs to, and this is how you set up a JK synchronous counter.